Today we're going to talk about torque. Torque is simply a twist. Let's start by looking at these two doors. Which door is easier to open and why? The door on the left will be easier to open. Now let's talk about why. Notice where the door handles are on each door. The hinges are located over on the right-hand side of each of these doors. But the door on the left, the handle is all the way on the other side of the door, farthest away from the hinges. This gives you more leverage to open the door with less force. The amount of torque required to open the door is the same either way, but since the radius or the distance from the hinges to the knob is larger on the door to the left, then the force required is smaller. Torque is calculated as the radius times the force required, and the letter for torque is the Greek letter tau. It is important to remember that the force must be applied perpendicular to the surface. When a system is in equilibrium, the torques must be balanced, meaning the amount of torque on the left of the fulcrum is equal to the amount of torque to the right of the fulcrum. The fulcrum is the pivot point. Keeping this in mind, let's work an example. Write this in your composition book, and then we will work through it together. Let's start by drawing a diagram. Todd and Dylan are on a seesaw, so let's start with the basics. Draw a seesaw. Then we draw our guys on there. And then I'll label them. This one is Dylan, and the other one is Todd. Now I will label it with their respective masses, and now the overall length of the seesaw, which is 6 meters. Whew, that was hard. Let's see what's next. Alright, Dylan is sitting on the end. Where does Todd have to sit to balance the seesaw? Remember what I said before. When it's in equilibrium, the torques must be balanced. So the torque provided by Dylan has to equal the torque provided by Todd. And recall that torque is equal to R times F. So I'm going to substitute R times F into this equation on each side. R for Dylan times F for Dylan is equal to R for Todd times F for Todd. Well, I don't know the forces provided by Dylan and Todd, but I do know their masses, and we know that F is always equal to ma. We also know that the force provided by each of them on the seesaw is provided by their weight, which means the acceleration here is going to be 9.8 meters per second squared. So I'm going to substitute mass times 9.8 in the equation for force. Since Dylan is sitting all the way out on the end, his radius is 3 meters. And then I plug in his mass times 9.8 equals the radius for Todd times his mass times 9.8. Type all of that in your handy dandy calculator, and you should find that the radius for Todd is 2.1 meters. This means that Todd will have to sit 2.1 meters from the center of the seesaw.